In the next two lessons we're going to look at energy level diagrams. First of all, we'll look at the energy level diagrams for exothermic and endothermic reactions, and then we'll look at energy level diagrams in the context of the use of catalysts. So what is an energy level diagram? Well, it's a way of looking at how the energy levels of the reactants in a reaction change as they are converted into the products. So first of all, let's look at the energy level diagram for an exothermic reaction. As you well know, we've got the reactants. In any reaction, they react together to form the products. And in an exothermic reaction, the energy level of the reactants are always greater than those of the products. So we place the reactants here at the higher energy level and the products down here at the lower energy level. Now, in order for this reaction to take place, you can look at this as a type of hill, right? And the reactants have to get over that hill. They have to climb over that hill and then down the other side, okay, in order to form the products. So the first stage of the reaction is to get over that hill. What has to happen for this to take place is that the chemical bonds of the reactants have to be first broken before they can react with each other. So this blue arrow here represents the energy required to break the bonds in the reactants. We looked at that in the previous lesson where we looked at energy transfer in terms of bond energies. Now this energy is also known as the activation energy. That's the energy required to break the bonds in the reactants. So the blue up arrow represents the energy required to break the bonds. The red down arrow represents the energy that is released when the new bonds are formed. So the resulting difference is the change in enthalpy of the reaction, and this is represented by the purple line. So you've got the blue arrow representing the energy required to break the bonds, the red arrow is the energy released when the new bonds are formed, and the difference between these two energies is the change in enthalpy of the reaction, represented by the purple arrow, and in this case the change in enthalpy is negative. That means that during this reaction energy will be released, and so the delta H is negative. Okay, so let's have a look at an endothermic reaction. So in our endothermic reaction, the energy level of the reactants is always lower than the energy level of the products. And so you notice that in the case of an endothermic reaction, the energy required to break the bonds of the reactants, represented by the blue arrow, is greater than the energy released when new bonds are formed in the reactants, represented by the red arrow. So the total change in enthalpy, this time delta H, is positive. That's represented by an up purple arrow. Okay, so this means that energy needs to be absorbed during the reaction in order for the reactants to react and form the products. So that is what you'd expect with an endothermic reaction.